All right, we are still on the concept of the inclined plane, and we are looking at the third example. It says an inclined plane of angle 15 degrees is used to raise a load of 4,500 Newton through a height of 2 meter. If the plane is 75% efficient, calculate Roman figure 1 the velocity ratio of the plane, Roman figure 2 work done on the load. So we'll first list out the parameters in that question before solving. First, we look at this. It is inclined at an angle of 15 degrees. Okay, let's draw the diagram first. Angle is 15 degrees. And then to raise a load of 4,500 Newton, this is the load. The load W is equals to 4,500 Newton. Okay, it is raised through a height of 2 meters. Through a height of 2 meters. So you come here now, this is the height of this load. The height is 2 meters. Height H is equals to 2 meters. Alright? If the plane is 75% efficient, calculate the velocity ratio of the plane. So we know that an effort will be applied here that will cause this block to move upwards. Okay? And this one now will show you the length of the inclined plane, which is the distance from here to here is the length of the inclined plane. From here to here shows you the length of the inclined plane. Okay, the length of the inclined. Okay, so now let's look at that quickly. Say we should calculate the velocity ratio of the inclined plane, and we know that velocity ratio is equals to 1 over sine theta. Okay, so that will be 1 over sine 15 degrees. Since the angle of inclination theta is what? 15 degrees. So now velocity ratio is 1 over sine 15. So it means that velocity ratio will be equals to 1 over sine 15 with your calculator. We give you sine 15 is 0.2588. So my velocity ratio now will be equals to, if I take the reciprocal of that, I will have, so this will give me 3.864. Okay, that's my velocity ratio. So I have this as the velocity ratio, 3.864. Now the next thing they say we should find is the work done on the load. So work done on the load is equivalent to, say, work done on the load is equivalent to the work input. Okay, that is the work that is put into the machine is equivalent to the work done on the load. So efficiency is the work output over work input times 100 in percentage. So efficiency now will be equals to the work output is load times distance moved by load over the work input is unknown, it's what you're looking for, times 100. So efficiency is equals to load times small l over the work input times 100. So we'll come back again to that. We are given an efficiency of 75%. Alright, so that is 75 divided by 100. Okay, the efficiency is 75%. They said if the plane is 75% efficient. Okay, so we are told that the efficiency is 75%. Alright, so if it's 75%, that's 75 by 100. If you convert to fraction, equals to the load is 4,500 Newton. 4,500 Newton times distance moved by load is 2 meters. That is the height of the inclined plane, the distance moved by load. Okay, the work input is what we are looking for. Work input. Right? That is it. You have the load as 4,500 Newton and the distance moved by load is the height of the inclined plane, which is 2 meters. So this now is 75 over 100 is equal to 9,000 divided by the work input. Okay, so if I make this subject of formula, I will then cross multiply. That is 75 times work input is equals to 100 multiplied by 9,000. Okay, so the work input now will be equals to 100 times 9,000 divided by 75. That is my work input will be equals to 9,000,000 divided by 75. And I'll be having my work input as, if I do the division, I'll have my work input is 900,000. Okay, 900,000 divided by 75 will give me, so this will give me 12,000 joules, or you can say the work input equals to 12 kilojoules. Okay, therefore work done on the load is equal to 12,000 joules or 12 kilojoules. Okay, so take note of that. So we have solved that question. So observe everything we did. We first found the velocity ratio as 3.864, and then we use the formula for efficiency. Is the work output or work input. The work input is the work done on the load. The work output is load times distance moved by load. The distance moved by load is the height of the inclined plane. The distance moved by load, sorry, is the height of the inclined plane. Sorry, is the height of the inclined plane, not the length, please. I'm sorry. The height of the inclined plane is the distance moved by load. So finally we solved, and we had the, let's say, efficiency is equals to load times the height of the inclined plane over the work input. We solved, and then we got this. We solved, and finally we have work input as 12 kilojoules, which is the work done on the load. Which is the work done on the load. We have another question on the board. It says a plane inclined at 30 degrees to the horizontal has an efficiency of 50%. Sorry. Calculate the force parallel to the plane required to push a load of 120 Newton uniformly up the plane. So this is the inclined plane, and then this is the horizontal surface. This one shows you the height of the inclined plane, height h. Okay. The length of the inclined plane is this. This is the load. The load is the block that is placed there, and it says it's used to push a load of 120 Newton, okay, uniformly up the plane. So this is the load, 120 Newton. So an effort is applied here. The effort will make this stuff, the block, to move upwards. The effort to make the block move upwards. So we have to calculate that force, the force parallel to the plane required to push the load up the plane. Now we are told that the plane is inclined at 30 degrees to the horizontal. So I come here now, write there 30. That's this angle of inclination. The angle of inclination is 30 degrees. Okay, it's 30 degrees. So that is it. And the efficiency was given to us as 50%. 50%, while the angle of inclination theta is 30 degrees. So we can find the velocity ratio. The velocity ratio of that machine now, say my velocity ratio is equals to the reciprocal of sine theta, okay, which is what? 1 over sine 30 degrees. That is 1 divided by 0.5 will give me 2. So my velocity ratio is equals to 2. Alright, that is it. Velocity ratio 1 over sine theta, which is 1 over sine 30. Sine 30 is 0.5, and the reciprocal of 0.5 is what? Is 2. Alright, that's the velocity ratio. Then we'll continue. You see efficiency E is equals to mechanical advantage over velocity ratio times 100 measured in percentage. Okay, so the efficiency was 50%, which is 50 over 100. That is 50 divided by 100 is equals to the mechanical advantage of that system is not given to us. That's MA divided by the velocity ratio is 2. Velocity ratio is 2. So that is 50 over 100 equals to mechanical advantage over 2. So now we can then cross multiply. This will multiply this, and this one will multiply this one. Okay, that's if I cross multiply. So I'll be having 100 times mechanical advantage is equals to 2 times 50. And I cross multiply this times this. Alright? So now mechanical advantage now will be equals to 2 times 50 divided by 100. That is 2 times 50 is 100 divided by 100. I have my mechanical advantage as 1. Okay? So my mechanical advantage is 1. As 2 times 50 gave me 100, divide by 100, the denominator which is 100. So if I divide by the denominator, 100 divided by 100 will give me 1. Now also we know that mechanical advantage is the load over the effort. That is the output force divided by the input force. Then I can make effort subject to formula and say effort is equals to load over mechanical advantage. When I interchange positions, I just interchange this and I have effort as load over mechanical advantage. Then that means that my effort now because to the load was given to us as 120 Newton. That is 120 divided by the mechanical advantage is 1. So 120 divided by 1 will give me what? 120. So therefore, the effort applied is 120 Newton. That is the force needed to cause this block to move up. The force that is needed to cause the block move up the plane is the effort, which is 100. That's the effort applied on that block to cause the block to move upwards. So that effort applied will cause the block move upwards, and the effort is 120 Newton. All right. Alright, we have another question on the board. It says a man pulls up a box of mass 70 kg using an inclined plane of effective length 5 meter onto a platform 2.5 meter high at a uniform speed. If the frictional force between the box and the plane is 100 Newton, draw the diagram of all the forces acting on the box when in motion and calculate the minimum effort applied in pulling up the box, mechanical advantage of the plane, velocity ratio of the plane, efficiency of the plane, work output of the man, energy lost in the system, and the total power developed by the man, given that the time taken to raise the box onto the platform is 50 seconds. We are given the acceleration due to gravity as 10 meters per second square. Alright, so let's continue. Let's solve those. We'll look at the first statement. A man pulls up a box of mass 70 kg using an inclined plane of effective length 5 meter onto a platform 2.5 meter high. So first we'll draw the inclined plane, and then we'll take the ground level. Now we are told that the length of this inclined plane, the length of the inclined plane L is 5 meter. Okay, the length of the inclined plane is 5 meter, and the platform, this is the platform, is 2.5 meter high. So let's assume that this is a platform. The platform is the vertical displacement from here, that's from this point to this point, is the platform. Now this is the height of that platform. The height of the platform is 2.5. So it is 2.5 meter high. This is 2.5 meter high. Okay. Now you place the block on that inclined plane. you take the weight of this block, weight is acting vertically downwards. So we say that the weight W is equals to mg, which is the mass of the block is 70 kilogram times acceleration due to gravity is 10 meters per second square. So I'll be having the weight as 700 Newton. But this weight is similar to the load. So therefore, the load now L is equals to 700 Newton. Okay? So this one now is showing us the load L, which is 700 Newton. So that is it. The load acting vertically downwards is the load. And the distance moved by the load is this height here, 2.5. Okay? Then the effort will be applied at this point, which will cause this block to move upwards. So this one now is showing you the direction of motion. Direction of motion is up the plane. Direction of motion is up the plane. Okay? Now if it is moving up the plane, that means friction force will act down the plane. Frictional force will act downwards, and it must oppose relative motion. Okay, so its friction force occurs between two surfaces in contact, and the surfaces in contact are the surface of this block and this inclined surface. So between the surface of the block and the inclined surface, the friction force will act. Now we are told that the friction force is 100 Newton. It said if the frictional force between the box and the plane is 100 Newton, so the friction force F is 100 Newton. So the friction force F is 100 Newton. F is 100 Newton. Now, at this point now, I'll have a normal reaction which will act at 90 degrees to this surface. So my normal reaction is R. 90 degrees to the surface, you have this angle 90. Okay. Now look for this angle. The angle theta is unknown, so I will look for the angle theta. Okay. Once I find that angle, then I can also put it here, angles in the same segment. Okay. So we come back here. This side facing this angle of inclination is opposite. So this is opposite side. And then if here is angle 90, if here is 90 degrees, then it means that this side now will be what? My hypotenuse side. So for a right angle triangle, the hypotenuse side always faces the angle 90 degrees. Okay, hypotenuse faces the angle 90 degrees, and this side that faces the angle of inclination is the opposite side. And that means here is adjacent. Alright, now I can find theta, angle theta. That is if I say opposite over hypotenuse, I've gotten the angle. Okay, so I can say sine theta is equals to the opposite side over the hypotenuse side. And my opposite side is 2.5. My hypotenuse side is 5. So if I divide it now, 2.5 divided by 5 will give me, so this will give me 0.5. And if sine theta is equals to 0.5, the angle of inclination theta will be equals to the sine inverse of 0.5. That means that theta will be equals to 30 degrees. So I have my angle of inclination as 30 degrees. Alright? So that is it. Sine inverse of 0.5 is 30 degrees. That's the angle of inclination. I will come back there now and I will indicate it. That angle theta is equals to 30 degrees. So it means that here is also 30 degrees. So then I will resolve this force over this way. And I'll be having the load, which is 700 Newton, 700 cos 30 degrees. So when I resolve this one this way, resolve it perpendicular to the plane, resolve it perpendicular to the plane, have 700 cos 30, and then resolve this one, resolve it parallel to the plane as well. So resolving it parallel, if I resolve the weight, this is the weight, resolving this weight perpendicular to the plane, I will have this. Resolving the weight parallel to the plane, resolve it parallel to this plane, I'll be having 700 700 sine 30 degrees. Okay, so when I do the resolution of the force, I resolve the weight of that block perpendicular to the plane, and I had 700 cos 30 degrees, and I resolved it parallel to the plane. I have 700 sine 30 degrees. So this is showing you the system of forces acting. We have the normal reaction that is at that point. Then over here now we have 700 cos 30 degrees. That is when I resolve the weight perpendicular to the plane, I have it. Then resolving the weight parallel to the plane, I have 700 sine 30 degrees. This is the effort, the minimum effort applied that causes this block to move up the plane. That's the minimum effort. Then you come here now, if here is 30 degrees, here is also 30 degrees. I say they are angles in the same segment. Angles in the same segment. And this is the weight of the block, which is the mass times acceleration due to gravity, is equivalent to the load of that block. Now you also observe that the distance moved by the load is the height of the inclined plane, which is 2.5 meter, while the distance moved by effort is the length of the inclined plane, which is 5 meters. All right. Now we have done the first thing, which they say we should indicate all the system of forces, and you also see how we obtained the angle of inclination 30 degrees using the trigonometric ratio sine of the angle. Okay, so we come back again to the question. It says draw the diagram of all the forces acting on the box when in motion. So we have done that, we have drawn all the forces. The diagram indicating all the forces, we have done that. The diagram that indicates all the forces, we have done that. Okay, so let's continue. Let's look at the next question. They said, next question there. Next question says, calculate the minimum efforts applied in pulling up the box. So Roman figure 1 says we should calculate minimum efforts in pulling up the box. First, we look for the normal reaction. So apply Newton's third law of motion. Say apply Newton's third law of motion. Newton's third law we're having the upward perpendicular force equals to the downward perpendicular force. So the upward perpendicular force is the normal reaction arrow. The downward perpendicular force is 700 cos 30 degrees. So that means arrow will be equals to 700 times cos 30 is 0.866. So we're having the normal reaction as 700 times 0.866 is so this will give me 606.2. Okay, that's the normal reaction, 606.2. Then you say upward parallel force equals to the downward parallel force. So the upward parallel force now is this one, the effort, and the downward parallel force. There are two downward parallel forces, 700 sine 60 and the frictional force F. Okay, but this one shows you the perpendicular forces, normal reaction, upward perpendicular, and the downward perpendicular force is this one, which is 700 cos 30. The upward one is this, the downward one is this. Now for the parallel forces, this is the upward parallel force effort, and the downward parallel forces, you have 700 sine 60 and the F, the frictional force. So I take the upward parallel force, which is effort E. Effort E equals to the downward parallel forces is 700 sine 30 and this frictional force. So I have 700 sine 30 degrees plus my frictional force F. Okay, see, but frictional force is equals to coefficient of friction times the normal reaction. Frictional force is the coefficient of friction times the normal reaction. Okay, however, we are given the frictional force as F is equals to 100 Newton. Okay, so supposing the frictional force was not given to us as 100 Newton, we can use this formula in finding the frictional force. The normal reaction has been obtained as 606.2 Newton, and the value of mu is is tan theta. Okay, and theta, we had theta as what? We had theta as 30 degrees. So supposing frictional force was not given as 100 Newton, so you use this formula, your mu is tan theta, you get mu, then put it into this value, you get the value of frictional force. You now multiply it with R, the normal reaction, and you get friction force F. But then we are giving friction force as 100 Newton, so there will be no need to go through this long procedure. Put the value inside here, and we'll be having that effort E is equals to 700 sine 30 degrees plus 100. Okay, so this is 700 times sine 30 is 0.5 plus 100, and 700 times 0.5 will give me 350. Add it to 100, I'll be having 450 Newton. That is the effort. The minimum effort applied is 450 Newton. So the minimum effort applied is 450 Newton. Okay, take note of that. Okay, so this was everything we did and how we arrived at the effort as 450 Newton. Now the next thing we should solve is the mechanical advantage of the plane. Mechanical advantage of the plane. Now we know that efficiency E is equals to mechanical advantage over velocity ratio times 100 measured in percentage. Okay, now we have to find the efficiency, the velocity ratio of the system. Velocity ratio of an inclined plane is equal to 1 over sine theta, and theta is 30 degrees, so this is 1 over sine 30 degrees. Okay, so my velocity ratio now will be equals to 1 over sine 30 is 0.5, which will give me 2. My velocity ratio VR is equals to 2. Alright, so velocity ratio is 1 over sine theta. Theta is 30 degrees, so that is 1 over sine 30. Sine 30 is 0.5 with your scientific calculator. Now 1 divided by 0.5 will give me 2. So my velocity ratio is 2. I can then make use of this formula, saying that my efficiency now will be equals to, okay, we suspend this first before we look for the efficiency. Let's first look for the mechanical advantage. It's a mechanical advantage is load over effort. Okay, we'll still make use of this formula. We have gotten the velocity ratio as 2, so let's find the mechanical advantage, load over effort. And we had the load as 700 Newton and the effort as 450. Okay, this is our load, 700 Newton, and then the effort E, we had effort E as 450 Newton. Effort is 450 Newton, so my effort now is 450 Newton. Okay, and that's my load, 700 Newton. The effort is 450 Newton. Okay, so when I divide it now, 700 divided by 450 will give me 1.56. So my mechanical advantage is 1.56. Alright, so that's the mechanical advantage, and then the velocity ratio is 2. Mechanical advantage is 1.56. Then we can look for the efficiency of the system. Okay, we have gotten the mechanical advantage, we have also gotten the velocity ratio of the plane, and let's look for the efficiency of the plane. The efficiency of that inclined plane, let's look for it quickly. So I'll look for the efficiency of the system. See, efficiency of system. The efficiency E is equals to mechanical advantage over the velocity ratio times 100 in percentage. Okay, so my efficiency now will be equals to mechanical advantage is 1.56. The velocity ratio is 2 multiplied by 100. So my efficiency now will be equals to 1.56 times 1.56 divided by 2 will give me 0.78 times 100. So my efficiency will be equals to 78%. Okay, my efficiency is 78%. Right, that's 78%. And the next thing they say we should solve is the work output of the man. The work output of the man Okay, so after finding the efficiency, the next thing they say you should solve is the work output of the man. So you say that work output is equals to the load times distance moved by load. So that is work output is equals to load times the height of the inclined plane. Okay, so that is it. So if you look at that diagram now, you see that the height of the inclined plane is 2.5 meters and then the load is 700 Newton. Okay, that is it. The load is 700 Newton, while the height of the inclined plane is 2.5 meters. 2.5 meters over there, that's the height of the inclined plane, and the load is 700 newtons. Okay, so that is the work output now is load times the height of the inclined plane. The load is 700 and the height of the inclined plane is 2.5. So that means my work output now will give me 700 times 2.5 is so this one gives me 1750 joules. Okay, that's the work output. 1750 joules is the work output. Is the load times the height of the inclined plane. Height of the inclined plane is the same thing as the distance moved by load, and the height of the inclined plane is 2.5. You multiply with 700, you have 1750 joules. Now the next thing there they say we should find is the energy lost in the system. Energy lost in the system. Energy lost in the system. And this is equals to the work input minus the work output. Okay, so it's the work input minus the work output. So how do we find the work input? You see efficiency is equals to work output over work input times 100 measured in percentage. Okay, so my efficiency now is 78%. Okay, see efficiency is work out over work in times 100. So efficiency is 78%, which is 78 over 100 equals to the work output. We had it as 1750 over the work input is unknown. Alright, so I can then cross multiply. This is 78 times the work input equals to 100 times 1750. If I divide by the coefficient of work input now will be 100 times 1750 divided by 78. So my work input will be equals to 175000 divided by 78, and that will give me, that will be, okay, so this is 2243.59. That's the work input, 2243.59. So that's when I divide this with this. Alright, 2243.59. Okay, so my work inputs is 2243.59, which is approximate to the nearest whole number, that is 2 to approximate 5 to approximate 9 to 5 is 6, approximate 6 again to this is 4. 2244 joules. This is the work inputs. Okay, now we have gotten the work input as this. Now there is another method of finding the work input. The work input is equals to effort times the distance moved by effort. Distance moved by effort, which is work input is the effort times distance moved by effort is the length of the inclined plane. Length of inclined plane. That is the work input now will be effort times the length of the inclined plane. And the effort is 450 Newton. The length of this inclined plane is 5. So let's see what we'll get. We'll have the work input. Our work input will be equals to effort, the effort times distance moved by effort, which is effort is 450 Newton. Distance moved by effort is 5. That will give me my work input as, that will be, so that is 2250 joules. Okay, which is similar to this 2244. So they just took it now to the nearest whole number, or I said they kind of approximated it to 3 significant figures. So 224444, taking it to 3 significant figures, they rounded it to 3 significant figures, add 2250. So I will take this one as the work input. So the formula we use there, basically work input is the effort times distance moved by effort. Now the distance moved by effort is the length of the inclined plane from that diagram. Okay, the length of the inclined plane, which is 5 meters. So finally we arrived at this 2250. That's the distance moved by effort, 5 meters. Okay. Now what they say we should look for now is the energy lost. The energy lost is work input minus the work output. So this now is the work input is 2250 joules minus my work output is 1750 joules. If I subtract this now, I'll be having my energy lost as, energy lost is 500 joules. Energy lost is equals to 500 joules. Alright. So the next thing we should find is the total power. Total power developed by man. Okay, that's the last question they say we should find. That's Roman figure 7. Okay, and we know that power is work done over time taken. Okay, so the work done there is the work output. That is the work done by the man. The work done by the man in raising the load over the time taken by that man. So the work done by the man in raising the load is the work output over the time taken. So it means that my power now will be work output over time. And the work output, we had the work output as 1750. The time, we are given a time of 50 seconds. So that is it. The time taken to raise the box onto the platform is 50 seconds. Time taken to raise this box onto the platform, or that's to raise the box onto the platform, is 50 seconds. So that is it. So the time taken to raise this block, the block or the box up to the platform is 50 seconds. That was the time given to us, 50 seconds. Okay. So I have my time as 35 joules per second. My power, sorry, as 35 joules per second when I divide it. Or I can say my power is equals to 35 watts. 35 watts. That is it. Power is measured in joules per second or in watts. That is it. Joules per second, or it is measured in watts. That's the SI unit of power. Okay, SI unit of power, joules per second or in watts. So the power now is 35 joules per second or 35 watts. So we have come to the end of this teaching today on inclined plane. This was everything we did. We got the work inputs as the effort times distance moved by effort. The distance moved by effort is the length of the inclined plane. So finally, we got the work input as 2250, and the energy loss is work input minus work output, which is 500 joules. Total power developed by the man is work done by over time. The work done is the work output over the time. So that would be power is work output over time, which is 1750 divided by 50 gave us 35 joules per second or 35 watts. Okay. So this is the diagram again. That one is showing you the direction of motion going upwards. And this is the effort. We had the effort as 450 Newton. And then these are the forces resolving this force this way. And the 700 sin 30. This one is 700 cos 30. Then the load is coming downwards. So just observe everything. The normal reaction that the forces acting on that system. Okay. And the work output of the man is load times distance moved by load, which is load times the height of the inclined plane. So we have load times the height of the inclined plane, which is h. We had the work output at 1750 joules. Then we got the energy lost in the system, work input minus work output. So this one is another method of finding the energy lost. I explained that using the efficiency, which is work output over work input times 100. We arrived at 2243 or 2244. When you round it up again now, you have 2250. Okay, so that is it. So this one now I say or okay, this is another method of finding the work inputs. Work input is effort times distance moved by effort. This one is the first method I use. Work output over work input times 100%, which is efficiency. And here I say work input is effort times distance moved by effort. Distance moved by effort is the length of the inclined plane. Okay, that is this length of the inclined plane. Okay. So you see that this formula is even more convenient. It's more convenient because it doesn't give you a decimal value. This second formula does not give you a decimal value. But this was what we got. It's more convenient. It doesn't give us a decimal value. It just give us 2250. Okay, complete whole number. But this other one will give us a decimal value of 2243.59. Okay, that was why I decided to go with this one. Okay, this other one, yeah, and then I neglected this. Okay, so that is the work input. The work input is this 2250. Now the energy loss with work input minus work output, 2250 minus 1750, which is what, 500 joules, and the power there is work done over time, which is finally give us 35 joules. Alright, we have come to the end of the teaching for today. Come to the end of the teaching. Thank you. I've come to the end of the lesson. God bless you. Once again, this is Mathematics Made Easy by Prosper Nodi, or Physics Made Easy by Prosper Nodi. Okay, we are still on the concept of machines. In the next class, we'll be looking at the next aspect of machines, perhaps the wedge or the screw, or perhaps we can look at the screw and screw jack. Okay, thank you very much. God bless you. Stay tuned.